That I'd like to introduce our head of cybersecurity AI engineering, Bartley Richardson.
Thanks, Nicola. Thanks everyone for coming. I know it's 10 o'clock. It's a prime time. Hopefully everyone's fed. A few housekeeping rules of myself. I have fallen off of a stage before because I like to move about, right? So if that happens, I'm probably fine. Someone here from NVIDIA, Nicola, will jump in. You'll still get the content, right, is what I'm trying to say. Leave me on the floor, get the rest of the content. So it's so great to be back with you. I know we've done a lot of these virtual events. When I came in, Monday, I think, is when I first came to the conference center when there was people here. It's very different than it was in 2019, which is the last time we were here in person, right? And I think different in a lot of ways. One, in 2019, we didn't have a cybersecurity track session, right? And I think it's amazing that we have this. And we talked a little bit about it inside of our rapid session, and there was maybe a quarter of this many people in the session, right? And so I think that is really encouraging that all of you are here and that we're all interested in cybersecurity. That's the number 2 biggest change. The number 1 biggest change is there is a lot more security than there was in 2019. There's security dogs and metal detectors. And it's a great time to be a dog, and it's a great time to talk about cybersecurity, right, at NVIDIA. Just a little bit about my background. I've been in NVIDIA for a little over 6 years now. Previously, was a computer science professor, theoretical CS, don't worry about that. Spent some time at DARPA, some time inside of the US intelligence community. And now I'm here at NVIDIA doing, engaging with the community, and we're going to talk to you today about generative AI. I don't know if anyone's heard of it. Generative AI is kind of a big deal, and we hear a lot of fear, and we hear a lot of how is this going to make our lives worse, and that's a valid conversation to have. But I want to talk to you today about how I think it's going to make our lives a lot better. With that said, let's go. I got a personal story for you here in just a little bit, so we'll get to that in just a second. Let's see, is this working? Level set, right? And I realize the audience that I'm talking to, so I don't have to spend a ton of time on this. Traffic, amount of data that we're generating is only going to continue to expand. You don't even have to look at cybersecurity to see this, right? You can see it with all the generative content that's out there today. You can see it with all of the additional appliances and devices and products and everything that people are plugging into their network to make it safer. Think about just what's happened in the last year. There's a lot of new companies and a lot of new products from established companies that are rolling out just to deal with fake content, generative AI content, right? So as we add capability, as we add these types of systems to our networks, the amount of data is only going to expand. I know probably everyone that's a cybersecurity practitioner in this room, you probably have complete visibility over every piece of data that crosses your network. You probably have no concerns. There's no blind spots. You analyze every piece of data, no problems whatsoever. I get it. But for those of you that do have that problem, right, we're talking massive amounts, 291 zettabytes, right, of data generated by 2027. How are we going to get a handle on that, right? And the consequences of successful cyber attacks continue to expand. And we're going to talk today about how we can shrink time, how we can accelerate those areas. I like to say there's a lot of different ways you can shrink time to detect, or you can make this kind of time to detect, move left of exploit a little bit better. One is make things go really fast, right? We at NVIDIA understand a few things. One of the things we do understand is make things go really fast, right? And I think when people think about accelerated detection, they think make things go really fast, and we're going to show that. Another way you can increase time to detect is you can have new capabilities, right? You can have new types of modeling. You can have new types of ensembles of models you put into your environment. Another way to make things go fast is to upskill the human or shrink the amount of time the human is working on a problem, right? I like to say that we're not interested in replacing any humans. I love all the humans. Every one of you today, we're all friends now, right? Call me. I don't want to replace any of you. But the reality is we don't have enough humans, right? So I couldn't replace you even if I wanted to and I don't want to. So how can we shrink the amount of time that the human is actually working on an actual problem? We know these problems exist, right? You here as cybersecurity people, you are at an incredible intersection of technology, of capability, and of problems. There's no bigger problem in the world than the cybersecurity problem because of the amount of data you deal with and because of the time, right? Things that happen yesterday, they don't matter, right? If it's taking you days to analyze, if it's taking you weeks to analyze, that doesn't matter. So the high velocity of those data streams, the heterogeneity of the data streams, the staffing shortage, which we already talked about, right? And the growing number of users, the growing number of alerts, these are all compounding the problems. And I have the next slide that's coming up, I realize is going to be a little bit controversial because I'm also in the cybersecurity business. But sometimes you just can't throw machine learning at the problem, right? I know. It's not magic, right? I like to say it's not magic, it's math. And what these are, here just to show you a few, these are incredible failures from some of the work that we've done, right? Massive, spectacular failures where we applied machine learning to try to solve these problems. And so, on the left, right, we're trying to cluster all of these types of anomalies. I'm sure you all have seen these types of things, totally indistinguishable clusters. On the right-hand side, terrible results from this confusion matrix. And so it's thoughtful application. It's thoughtful, when you approach these problems, it's being thoughtful about them. And we talked about those ways we can accelerate, right? One way that I think we all realize is not the way is you're just going to throw machine learning at the problem and hope for the best, right? I think we all realize that that's not going to happen. At the same time, rather than just throwing it at it, thoughtful application of detection can be successful. And I want to share a few examples of this with you. This is specific, and we're going to get into a lot of technical details here in a bit, just setting the stage. This is using our cybersecurity framework that we call Morpheus for a lateral movement detection model, right? And this is where I think customized AI, and I strongly believe customized AI, can be very impactful. When you have specific use cases, you've thought about your data, and you apply the correct model and the correct modeling process to that, you can get really great results, and you can do it incredibly efficiently. Right? So this is an example of where we've taken a lateral movement model and shrank that down from 416 servers, CPU servers, and you can run that now on a single GPU server. Right? So not only is it the application of the model, but it's the application of the technology that is going to allow you for that increased visibility. Another example, if we're just talking about pure data ingest, right? Pure data ingest. You've got all this massive amounts of data coming in, terabytes, tens of petabytes, lots of data coming in. You want to be able to have visibility into that. Even if you're not storing it, you want to be able to see it. We can now take that data, give you a speed up of data ingest around 38x with a 59% TCO reduction, right, across that. What does that let you do? It lets you focus on the things that you are experts on, right? Like, don't worry about the data collection. Worry about what's the right model to apply, what's the right ensembles of models to apply. And of course, it all factors into TCO. Why am I telling you all of this, all of these things that you already know? It's to hammer down the point that we can deal with data ingest as a community. We can deal with data ingest now. We understand thoughtful applications of modeling. And then bursting through this kind of wide open door is generative AI, right? So you have all of the same problems that you already had, right? You have how are we going to deal with data ingest? How are we going to do with modeling? Enter generative AI and the growth that that's going to represent in cybersecurity, right? 70%, right? One estimate will incorporate some type of predictors or some type of generative AI in the coming years. And that's what I want to talk with you about, right? Like, how can we actually leverage and how can we use generative AI in a few different vignettes? I'm not going to spend a lot of time on the Morpheus cybersecurity framework. I'm going to put this up there just to show you that this exists. We have links that you can follow, and you can learn all about it. We have a lot of content on this. We have trainings on it. We have examples. We have videos. There'll be a Cyber Developer Day tomorrow from 8 o'clock to noon that you can register for, where our tech leads are going to walk you through how to develop inside of Morpheus. They're going to show you a generative AI application. You can get a lot of hands-on experience there, right, as well. But what Morpheus does really well is it eliminates from you, right, or it absolves you of having to deal with, how am I going to deal with all of this data, and how am I going to deploy quickly, right? Because let's face it, is anybody a CUDA expert in the room? Not you, Matt. I see Matt right there. He was going to raise his hand. Matt's a CUDA expert, right? And Matt works for NVIDIA. Anybody a CUDA expert in the room? Right, exactly. I think NVIDIA employs all the CUDA experts in the world, right? But we want you to take advantage of CUDA, but we don't want you to have to be a CUDA expert to do that. Application frameworks like Morpheus let you do that thing, right? Like if you're a Python developer, if you're a C++ developer, you can develop inside of this framework that hits all of the lower-level CUDA, CUDA-X frameworks, and you can take advantage of that parallelization. You can take advantage of that optimized compute across GPU, x86, ARM architectures without having to be that. Everything that I'm going to show you today, right, is developed inside of the Morpheus framework. It's open source on GitHub. We also have it available as NVIDIA AI Enterprise, right, that you can license. OK, with that being said, generative AI. Probably when I say generative AI and I say cybersecurity, you think Copilot, right? Like everyone thinks Copilot, and I agree. Copilots are a fantastic use of generative AI. Why? Because they're helping the human aspect of it, right? You're accelerating the human. You're making the human's job a little bit easier. And I think it makes sense to start with copilots, both for your staff and for your customers. But what are the ways that we can start to put generative AI and language models further down into the cybersecurity stack? And those of you that came to our LLM Dev Day probably saw the graphic on the right-hand side, right, where we're saying, here's how we think you can push that and you can actually harness and utilize those generative AI and LLM capabilities further into the stack. One way is for synthetic data generation. And I'm going to talk about that a little bit today when I talk about our updates to CyberGPT, right? Back at LLM Day, we talked about synthetic data generation for spear phishing. And we have a spear phishing DLI, right, that you can take. And the goal there is addressing a data gap, right? When you think about spear phishing and you think about successful spear phishing campaigns, the only difference between a successful spear phishing email and a legitimate email is the intent of the sender, right? And so how can you generate and then detect these incredibly sophisticated and well-written and very well-created spear phishing emails? That's an example of using synthetic data generation to cross a data gap for cybersecurity. And we'll talk about that in our foundation model. Another example is when we talk about copilots, and that's the one I'm going to show you here, agent-based work. So taking what would require hours and days for a human to do and incredibly shorten that gap, right, to minutes, to seconds. And that's what I want to start with. And so we're going to call this thing Agent Morpheus, right? We tossed around a lot of names for this. And I'll tell you something, the cyber team is not, I'm not going to even include them. I'm going to tell you something I'm really bad at, naming things. Because if I had my way, this would be called the CVE tool for vulnerability and exploitability analysis, which I think is infinitely better than Agent Morpheus, right? But okay, we'll go with Agent Morpheus. It sounds cool. It evokes a Matrix style, thing in your mind for better or for worse. I haven't decided which one that is. And so we're going to talk about all the details. I'm going to show you how it worked, but we have a quick video.
Enterprise applications are composed of many software containers, each involving a complex set of dependencies. To triage a container for vulnerabilities, hundreds of pieces of information need to be retrieved, understood, and integrated. A tedious process that can take days. Let's look at how we use generative AI to shorten the process to mere seconds. This is Agent Morpheus, built using NVIDIA Inference Microservices, NeMo Retriever, and the Morpheus SDK to create an event-driven, retrieval-augmented generation application. A fine-tuned large language model scans the container and generates a customized checklist. that matches a standard security VEX document. The agent executes many perceived reason act loops. Under the hood, it's like the system is talking with itself to reason through the analysis. This continues until the application examines the full checklist. Within seconds, a summary is presented to the human decision maker to determine if the container can be published. Thousands of these Morpheus AI copilots are used by NVIDIA's own engineers, continuously scanning vast amounts of software in an ever-changing landscape of security threats.
Okay, so Agent Morpheus sounds better in the video, right? Like, I get it. Okay, you're right about that. And this is what it is, right? So you kind of saw the video, but let's talk a little bit about the details of it. What's the top line? What's the goal? You have, is anyone familiar with this thing we call software? Yeah, okay, software, great, fantastic. We're all on the same page. To deliver software, right, a lot of the world's software, a lot of the world's applications rely on container-based software development. And that's how we deploy, manage, update a lot of software. And at NVIDIA, we have software that's part of our production branches. That's part of NVIDIA AI Enterprise. And part of our promise and guarantee when you subscribe to that is you're going to get a container that is free of critical and high CVEs, free of vulnerabilities. The issue arises when we have these containers. They're published. They get scanned by traditional scanning tools. And we get a list out, right? And the list says, oh, you've got these criticals. You've got these highs. Here's a link for the CVE notice on NIST or GitHub or Canonical, wherever it is. Go fix it. And that's not a lot to go on. So what happens is the human, the container engineers, they'll go and they perform a lot of work. It's a manually intensive, it's a human-intensive process to do this. And they gather all this information. And I don't have to tell you, the world runs on spreadsheets, right? They put it in a spreadsheet or something spreadsheet adjacent, and then they make that final determination. What Agent Morpheus does is it doesn't make that final determination. The human is still in the driver's seat, right? The human is still in charge. It does everything else, though, right? And we've got some some live demos, right? So it's an agent-based approach that we've connected to not just the internet, but we've connected to all of our internal information about our code repos, our documentation, our software bill of materials, our SBOMs. We've connected it to discussion forums. We've connected it to waiver information. So if you think RAG applications, right, traditional RAG applications, that's what we've connected it to. And the team has created customized tools, so version comparison tools, container security tools, and all that. And the system has access to that as well. A little bit more detailed diagram, right, kind of looks like this. I want to walk you through how it works, and then I want to switch over to the live demo. And I'm not stalling just because nothing ever went wrong with a live demo, right? Like, you know, nothing ever went wrong. But I want to make sure you understand the process here. So in the middle, right, if you're looking at the kind of the orange, or I guess it looks a little reddish box in the middle, that's the agent. And you heard in the video, this executes this perceived reason act loop over and over and over again. What happens is, for ease of use, we've designed this diagram to be read right to left, which is how I think everybody reads things. So we've got down there at the and bottom to top, right? So right to left, bottom to top. Security through obfuscation. Anybody? Right. So right to left, bottom to top. If you look at build container there on the bottom right, container is built. Security scan is run. This is what's happening in all of your enterprises today, right? After that, that's where Agent Morpheus, and that's where this kind of takes over. You're going to see there's multiple kind of LLMs that are a part of this. Don't be afraid. I'm going to tell you all about them. The first one is it says checklist task generation model. So this is an LLM that we have fine-tuned, we've LoRa-tuned to match a standard security VEX document. And so what happens is we take these security results. We know about the SBOM. We know the CVEs. There'll be a huge list of them potentially that are in that container. We go and we gather a bunch of information from the internet. You know, hundreds of internet searches to grab every piece of information we can get about that particular CVE, about that advisory. We bring that back in. We know the container, the SBOM, like I said, and we ask that LLM, OK, you know about this container. You know everything about this CVE. Generate for me the checklist that I would need to take as a human to be able to triage, mitigate, right, or determine if these CVEs are in this container and am I exploitable by these CVEs, right? It's not just enough to know are they there. You also want to know if you're vulnerable and exploitable. And that's not a human that generates that checklist. That's the first LLM in this process. That thing gets us into that middle loop. So you see that checklist that's been generated. And then the agent is going to just start ticking off all of those actions, right? It might be it might be 4, 5, 6, 7 different items on that checklist. And the agent is just going to keep running through those checklist items. It's going to go and it's going to generate a prompt. The agent has access to all of this information that I told you about, right? It's hooked up to our various different vector databases for our code bases, our developer guides, our SBOMs. It has all of these tools that are associated with it. It's going to get an answer back, and then it's going to execute the next checklist item, right? Standard agent-based approach, right? No worries. Once that's all done, you're going to have a mess of text, right? That's a bunch of checklists. It's a bunch of results and a bunch of things to do. That gets then sent out to a different LLM that is going to summarize all that information. So you've got perhaps pages of text. And now we say, OK, great. You've ran through this checklist item. Summarize it for me. Right? You're going to get a snippet summarization of it. And also, give me the VEX justification for your decision that you made. And that answer, that VEX justification and that summary of the whole conversation is what gets presented back to the user on their little dashboard, and the user can then say, yes, I agree with this, no, I don't agree with this, I can expand it all out, and I can determine what I want to do with this. And this takes, it depends on the container, right, how big the container is, but in some of our worst case scenarios, this whole process takes around 90 seconds to execute. And so, like I said, because nothing ever went wrong, let's just show it. What's the worst that could happen, right? We're all friends, right? Like, so if it goes poorly, don't video it. Only video it if it goes really well. So a few things that we have to talk about here. I realize that I'm showing you a Jupyter notebook, and I realize that your enterprise security does not run on Jupyter notebooks. What I'm asking is for you to realize that it's really hard for me to open the box on something that's automated as part of our pipeline systems, right, at NVIDIA. So what the team has done is we've pulled that out, and we've put it into this notebook so that you can see what's happening. In the reality, in the real case, you would never see this kind of inner workings, right, of the system. You just get the summary at the end that you can expand. But I wanted to show you it, and there's a couple different vignettes that we can have here, right? So I'm not going to run through all of them because we got a lot to cover today. But I do want to show you this one, and the other. Just as an aside, this was all in light mode before yesterday. And then the team was like, well, we're going to be talking to security people and developers. And I was like, yeah, is there a problem with the notebook? It's broken. And they're like, no, but it's not in dark mode. And so it's in dark mode just for you because we recognize that this is important for you. One last piece of setup. I've specified a specific container and a specific CVE. That's not how it works in practice. Again, the container gets generated, and then it runs, and there's going to be a whole list of CVEs. But if I put all of them here, it's going to be really hard for you to see and really hard to keep track of, right? So imagine this happening in parallel for all of the containers, right? And I'm going to go ahead and run this. So what's happening first is I'm going to have to run this a few times because I talk to, as Nicola said, I can talk, right? And so I'm going to talk longer. But what's happening when we say collecting the latest information about this CVE, that's where we're going out and we're searching the web. We're pulling in all of that content. We're running that through chunking, embedding, storing, right? That's all happening in real time. The other thing I haven't mentioned yet is this is always up to date, right? Because it always goes and it pulls information. If you don't want it cached, you can cache it if you want. And there's different caching strategies. But it'll always go and it'll always be up to date. It pulls all the information, and then you're going to see it generates that exploitability checklist for you. That's where we have that first LLM model, and it's saying, hey, I have this CVE, I have this container. How can I figure out if this CVE is in this container and if this container is exploitable to this CVE? And so I'm going to run it again because I talked too long. Right? Again, happening in real time, and you're going to see the checklist pop out. And you'll just have to trust me that it's going to print out because I want to walk you through it just so we're on the same page. So you're going to see this is checklist item number 1. Typically, the first item that it comes up with is it a false positive, right? And to be fair, it's the first thing I would check too. So it's going to say, OK, I need to check the SBOM to see if this container actually does contain this package, and it contains the version of the package, right? So does it have the Python binary before 3.11.4? And you'll see the executor chain here. This is actually calling out to OpenAI, right? So it's completely customizable. You can plug it into whatever kind of LLM that you want for the agent part of it. And so we say, like, OK, we got to check the SBOM. And then we get this observation, this thought, and then the finished change. That's the perceive, reason, act loop that we were talking about, right? The Python binary, it is in the SBOM. It is the correct version, right? And so we get the answer, yes, it's there in that, and it's the version that is actually exploitable. The next question, right? Does the code base contain this particular function that is mentioned in this CVE? Right, that can be exploited. And so now we're going to do the second loop inside of that agent. Now in this instance, we're going to reach out to our code base and our documentation, right, whatever we have. And we're going to say, OK, it's not there. Right? The code itself does not directly call that particular vulnerable function. And you could stop there. Right? I don't think you should, but you could. You could do a lot of things. But we finished that checklist item. The next thing that, again, the LLM has said we need to do, OK, it's not there in the code base, but do any of this container's direct dependencies contain this vulnerable component, right? So we're going down into the stack for this. And we'll say, OK, the open source direct dependencies, I'm speeding up for time, but the open source direct dependencies aren't actually in there. Indirect dependencies may exist. So there might be dependencies that I don't have access to as my agent, but I couldn't find any that I have access to. And we could stop there, right? But you shouldn't. Right? We go one more layer deeper, and we'll say, OK, the version is there. It's not in the code. It's not in any of the indirect dependencies. What is this container even used for? What's the intended purpose of this container? And is it likely that someone would even be using this function for this intended purpose as well? And then you're going to see this is where it's going to our documentation, all of our public and private. This is what this container is for. Here's what we've published about it, right? And saying, OK, this particular function supports making HTTP requests, handling cookies, all this kinds of stuff. This container is not a web-facing container, right, to do this. So it's unlikely in this scenario that you would need this function inside the container. Keep in mind, we've already determined that it's not there in the first place, right? These are additional pieces of information. We then finish this particular checklist. There was only 4 things on this one. And that's when we go back out. We pop out of the agent. We ask the LLM to summarize it for us. And here's what we get. This particular library, the URL library, supports making these requests. The container is not intended for this. It's not there. And we get the VEX justification back, right, that aligns to a typical VEX justification. Vulnerable code not in execution path. Right? Let me, as I'm talking to you, let me run one more. This one is actually an exploitable answer. So there's all the permutations that you can have, right? So that one was, hey, not exploitable. You should be good to go. We would push that back out to the human to make the final determination. This is a slightly different one. This is, we won't have to get into all the specifics about it, but we're checking for a specific version of ML flow in this particular container. So that's checklist item number 1. We need to understand the impact of this particular vulnerability. So the checklist that is going to be generated will be different and context sensitive based on the container, the SBOM, the code base, and the CVE itself, right? It's highly correlated. We get to the end here, right? And we say, OK, this actually is exploitable in this particular Morpheus container. It's a critical vulnerability. I can't read it from that far away. It's advisable to immediately patch it. It tells you information about the potential consequences of this. And this information is then you bubble that up top line to your build engineer that they can say, oh, yeah, OK, I do need to patch this particular version. Here's my VEX justification. And then if they want to, what's nice is they can go back and look at all of this reasoning chain, right, if they want to expand that out. And that's the way I was saying, I don't know if you've tuned in some other talks, but I like to say it's only AI until you trust it. As soon as you trust it, it becomes automation. And this is a way where we can foster that trust with the human, with the engineers, and we can say you have full visibility into our reasoning chain or your reasoning chain for your software. There's a lot of other examples we could go through. I will save that. Again, slight plug for tomorrow, Cyber Developer Day, 8 to noon, where we're actually going to go through this particular example. Okay, let's get back to where we were. You already know all this. Right? That was the CVE. We'll take questions at the end, so I'm happy to take questions at the end. The thing that I really like about this is not only is it cool, right? I think it's cool. But not only is it cool, it's performing an incredibly valuable task at NVIDIA because it frees up these limited amounts of humans to not do all of this trivial kind of gathering and synthesizing information. What you didn't see when we ran this demo is it executes over, 200, 300 different web searches. There's over 500 different calls to our internal tools. I'm on our VPN right now, right? So it ran live on our systems. And that all happened in the matter of seconds and then brought you that information back to you. So the amount of acceleration is fairly impressive. And again, it's taking AI and it's making it automation, right? How can we foster trust and how can we do that? That was the cool demo that I have for you, and it worked. So I think we're all happy. We could stop while we're ahead, but let's talk about foundation models. A little bit about me, because no one asked, but a little bit about me. I grew up in a farm in Ohio, right? And if you're not from the U.S., there's not a lot to see in Ohio. It's pretty flat. There's a lot of cattle, and that's where I grew up. And my grandfather was a farmer, and it was instilled in me, as only a farmer could, that there's a right tool for the right job, right? And I will say that applies to cybersecurity as well, right? We're talking a lot about generative AI today, and we're talking about foundation models, but it does not mean that we throw everything out, right? We're going to look at traditional machine learning. We're going to look at deep learning. And I'm a big believer in if I can solve something by counting something really fast, I'm going to count something really fast. If you tell me I need regression to do that thing, I'm going to use regression. If I need ML, I'll use ML. If I need DL, I'll use DL. And if I need generative AI, I'm going to use generative AI, right, to do it. But it is a tool that you can use and not a replacement for everything else. And we got asked a lot of questions. We were like, what about foundation models for cybersecurity? We talk about foundation models for medical, foundation models for these other things. What about foundation models for cyber? And my take on that is there is going to be utility for those foundation models, but they will be very specific, and they're probably not going to be for everything. No one tell Jensen that I said this, right? We're all friends. No one tell Jensen. But they're going to be very targeted. You have to be very specific with this. And I want to show you one that we came up with, a foundation model for red teaming. If you were at LLM Day and you viewed that online, and you can go back and view it right now, right? You can view the video online. We were talking about foundation models for traffic generation, right? And what we wanted to do was train a foundation model from scratch for cybersecurity to generate logs that were so accurate for Bartley, for Nicola, right? For Matt, who I talked about earlier. I won't call anybody else, just the people that you already know. That they were indistinguishable. And then I could gamify a lot of situations. Well, what would it look like if Bartley was traveling across the country and his role changed and he forgot his two-factor authentication? And I could train lightweight detectors on that type of telemetry, right? It sounded right? Like, it sounds pretty cool. You can gamify this whole thing out. Massive failure. So we pivoted, right, a little bit. And where we took that work was into red teaming, right, with foundation models. And so let me do a slight pivot for you and talk about red teaming. Any red team people in the house? Nobody. One. Okay, sort of. Okay, so if I say anything wrong, keep it to yourself. No, red teaming is so important and so valuable, but there's a lot of challenges. Time consuming, the time, just to plan a successful playbook for a successful red team, right, is human intensive. You often have to set up outside infrastructure to do this, and it's very difficult and very hard to do well. We don't have enough people. Your attack surface is constantly expanding. I don't have to tell you this. And there's new techniques all the time. And so with generative AI, what if we could solve that data gap? What if we could train foundation models that are so specific to your network and your environment that you could synthetically generate not the attacks, but the results of the telemetry as if an attack had happened on your network, right? That's what we did. And we ran through all the possible options, right? And kind of broke them down into 3 different areas. One is you could do this with just a vanilla, out-of-the-box LLM, right? Pick your favorite LLM and ask it to do this for them. It's great for out-of-the-box reasoning, but we could not get it to consistently give us valid, authentic logs to a particular environment. You could go to an ensemble, right? Or you could do a foundation model to do these types of things. And I think I already spoiled the end, right? Like we're doing this foundation model because it creates rich, authentic logs that can align to your environment. It's typically unable to reason or understand the context of the raw logs, but that's not what we're using it for, right? We're using it to gamify out situations so that we can observe things that might be one-offs, that might have never happened in your environment before. It requires specialized talent, though, and that's the great thing about something like Morpheus and NIM, which you heard about before, is we can kind of make this research and make this available to you, and then everyone doesn't have to be a CUDA expert. Everyone doesn't have to be this expert, and you can use it immediately. Here's some examples, right? So what I'm showing you here is logs that have been generated by our red teaming model, and this one is specifically for SharePoint logs, right? So the data here had around 630 events that we generated that represented, and we went back and tested this with our red teaming, valid SharePoint access events. Data helpful is essentially we use it to test our SharePoint kind of security procedures. And out of these like 600 and some events or whatever, 90%, right, a little over 90% of these events were related to password sites where a password is shared or accessed out of context and all these types of things, which is no one else has this problem of like wide open SharePoint sites, right? Probably, but it's this ability to and don't focus so much on like, okay, it was a wide open password site. The interesting thing here is we're able to align this foundation model so that it produces what would our actual telemetry look like if this like had occurred or someone was accessing these like wide open like SharePoint sites, right, without having to go through that. We're working to expand this. So think about attacks that you, in red teaming, you might need to set up that requires outside infrastructure, DDoS type style attacks, right, and things like that. You can do that without needing to set up that outside infrastructure now, which I think is really cool. That's foundation model, ongoing work, ongoing research. And we can talk a little bit more about that. We have a Connect with the Expert session happening, I think later today. Is Connect with the Expert session happening later today in Pod A? So come talk to us about our foundation model work, and we can talk about fine-tuning, training from scratch, all that kind of stuff. We have a lot of information, best practices, all that. If you've seen, the last thing I want to talk about is digital fingerprinting. Digital fingerprinting is one of our workflows that we've had out for a while now, so I won't go into all of it. But the idea is that you create a model that is so customized to your environment, to your person. So at NVIDIA, for example, we have, like 26,000 employees. We create 26,000 models, one for every employee. So it's the Bartley model, it's the Chow model, it's the Nicola model, it's the Abdul model, right? I see my friend Abdul in the back. And then we're able to train those models, inference across them, and accurately predict if you're behaving like yourself. So it's user behavioral analytics to the nth degree, right? Because we have this massive amounts of data and logs and all those kinds of things. And I won't talk about the foundations of digital fingerprinting. There's a whole blog, and if you go to our website, nvidia.com/cybersecurity, you can see all of this. What I want to say is that we took digital fingerprinting and we're using it for other applications now. We turned this loose on essentially Linux audit logs, right? To look for anomalies in these massive amounts of like highly detailed and slightly esoteric, these audit logs for our Linux boxes. And so we trained this, and I have information for you here. We trained this, and then we run it through the inference pipeline, and we're able to detect anomalies in these Linux logs. It's not people that are not behaving themselves, but it's systems that might be experiencing issues. It's systems that might be experiencing malfunctions and things like that. These are the results from it, right? So if you look over on the right-hand side, the charts are great, but what I want to call your attention to on the right-hand side is just the infrastructure that's required. So for the training pipeline, right, we use 90 million log lines, 100 epoch. We had a massive Spark cluster that they were already using to do the data ingest. But to train this, we used a single Tesla version GPU, right? And when I mentioned digital fingerprinting deployed at NVIDIA across all of our employees, that is 4 A100s. Right? So this is not a superpod conversation that we're having, although I'd love to have a superpod conversation with you. It is not a superpod conversation. It is a incredible amount of power packed into the tiniest amount of GPU possible, which is a terrible sales play. But just the amount that you can do on a single GPU is incredible. To do the inference, we also use a single Tesla GPU for that, right? And the model pipeline inference time takes around a minute, right, to do this. And so you can look at hundreds of thousands, right, of these Linux anomaly logs, and you can do that in real time. The last thing that I wanted to talk about was speed and data ingest. And we've been working with, if you talk about speed and data ingest and embedding and all of these types of things, we've been working with our friends at Pure Storage. I believe the future is everyone's going to want to represent their data in a way that can be accessible by generative AI, right? The CLI is going away, enter the human language interface, right? And so we've been using, all these pipelines that I've been talking with you about, the pipelines that support digital fingerprinting, the pipelines that support Agent Morpheus, the pipelines that do all this other stuff. We're using the same pipelines and NVIDIA microservices, so NIM, and we've worked with Pure. So you can do that embedding, the chunking, the tokenizing, the embedding of documents as they're entering your store in near real time, right at the storage device itself, right? So you're not round-tripping this through your entire environment. You're doing this, on the Pure Blade, right, itself, and then you can query that as it's being done. We actually, Anna Runda's right here. She's in the second row. Raise your hand, Anna Runda. This is the engineer that's done all that work. It's incredible work. You should come talk to her about that work. But the point I want to hit here is that it's the same pipelines, right? If you're doing digital fingerprinting already, if you're doing Agent Morpheus, if you're doing these other things, these use cases that we have, it's the same thing that we're using for document ingest and to do all of this. I showed you this at the very beginning. This is how we envision, pushing large language models and generative AI deeper into the cybersecurity stack. But I lied to you a little bit because this is not how you do it. This is how you do it, right? Right. But 30% of you would have walked out, right? If we put this up at the beginning, this is how you do it, right? And so if you look at the, and I won't explain it, all the way because we just don't have time. But we make this available to you. Think of it as a reference architecture, so you can hook up these Morpheus pipelines that do direct inline processing of your data, and you can route it to the appropriate part. Are you doing, at the top, Copilot that we talked about? Are you doing synthetic data generation, which is the second box? Are you doing foundation model training? Or are you doing analytics and inference? Your deployment becomes, and you're going to laugh, your deployment becomes easy. I guess, right? But it becomes easy because you're reusing so many of these pipelines that you get as part of the Morpheus SDK. Last thing, and we have some time for questions. Upcoming release of Morpheus in 2403. We have a bunch of things to the LLM engine, support for Agent Morpheus, right? So if you're tracking that on GitHub, you can get all of that with 2403 here happening this month. Number of different bug fixes, new CUDA versions, and then in the future. If we're talking about microservices, we're going to make it really easy for you to do log parsing and deploy these microservices coming in July. And then past that, we're scaling out further multi-node, multi-GPU development, all that great kind of stuff. You can find a lot of information on our website, nvidia.com/Morpheus, nvidia.com/cybersecurity. You can DLIs, developer guides, all of these types of things are all available for you. And then I wanted to end with some of our partners who are already working with us. If you saw Jensen's keynote, right after the keynote yesterday, we announced our partnership with CrowdStrike. So CrowdStrike is using Morpheus inside of Falcon for their AI-powered security. You'll be able to learn more about that. Also at Cyber Developer Day tomorrow, we'll have CrowdStrike there. that can answer all of your questions. They'll be doing a presentation there. Also, our friends at Deloitte, who have massive amounts of cyber capabilities across the world, have integrated Morpheus for their technology as well. More to learn here at GTC. Come see us at the Dev Day tomorrow. Come to our Connect with the Experts session later today.
Thank you, Bartley. Thank you, Bartley.
Thank you for faking that mic moment so they felt the awkward pause and needed to applaud. I appreciate that. We worked that out.
So I set up Mike in the middle because there's so many of you, so thank you all for coming. If you have questions for Bartley, feel free to make your way to the mic or raise your hand, and I can bring you this one.
Just a quick question. Since the pipeline's not being orchestrated in a Jupyter Notebook, what is it being orchestrated in? Is it LangChain or something like that, or a different platform?
Yeah, exactly. So you can, the short answer is you can kind of use whatever you want. We have the version that you just saw is LangChain Llama Index, right? But we have a version of it that also could run Retriever, right? If you're interested in Retriever for that. There's only text retriever right now, and we needed these other types of retrievers, so we orchestrated those in Llama Index. But all you do for that is you would, and they'll talk about this tomorrow, you would take your Llama Index like code and you wrap it in our Morpheus stage decorators, and then it becomes part of your pipeline itself. Nicola.
Hi, that was really good. In the slide with the pure storage thing, where is that NIM running? Is the container like in the pure storage infrastructure?
It's in a GPU, right, that we've set alongside the Pure Blade.
Okay, so it's just like sitting on the network next to it.
Yep.
Got it. Thank you.
There's a future vision where that becomes a consolidated piece of hardware.
Have you experimented with using multi-agent workflows with frameworks like AutoGen, for example?
Yeah, not with frameworks of like AutoGen. We haven't, right, with that specifically. We have looked at multi-agent workflow. So where I think that's going to be really interesting, I didn't talk about it. We're going to blow that like CVE basic architecture like out a little bit and think about it using it for, now it's not for CVEs. It's like, oh, I made a policy change on this box, right? Like now, am I still in the best possible security state for my environment given the policy change I just made? It's Grammarly for cybersecurity, right? Like think about it that way. I think that's going to become really interesting.
Sure, and a follow-up question. Have you tried having agents execute code to try and exploit vulnerabilities?
We haven't tried that, actually. Some of our partners are working on that, which I think is interesting. We haven't done that ourselves, though.
All right, cool. Thank you.
So for Morpheus, which parts does the LLM have an advantage over just scanning a list of Python requirements, like more classical implementations?
Yeah, for CVEs specifically? Yeah. It really has the advantage because it's hooked up to so much more kind of additional data, and the real advantage of the LLM there is inside the agent. I didn't talk about it, but that's where we're using, like, there's an LLM inside the agent. It can look at all that data and synthesize, very kind of short synopses from those multimodal sources. And so rather than like scanning through lists, which is useful, right? Like if I can have like this list here, I can kind of like make my way through it as a human. It's that next step where we've taken that, in the old days, I would call that data fusion, right? But now I'm calling it like RAG and synthesization. We're taking that and we're doing that and presenting that up front for you. And so there's an added layer of reasoning versus kind of like the list and traditional data fusion.